guys, welcome back to our YouTube channel. Today we want to find the value of x, given that you have open bracket square root of x minus 1 all to the power of 3 equals 5 to the power of square root of x minus 1. So now guys, how are we going to solve this problem? Somehow is a little bit difficult, but to solve it easily, let's say we have square root of x minus 1 all to the power of 3 equals 5 to the power of x minus 1, square root of x minus 1. Now to make it simple, let us reduce this. So far this and this are the same. We can say let square root of x minus 1 to be equals a. And so from here, this implies that we have a to the power of 3 equals 5 to the power of a. Now from here, the next thing we can do is let's introduce natural log to both sides, because it looks like a solution where we can apply Lambert W function that says Lambert for W function of a, then multiplied by e to the power of a, then this will give us back our a. So far the base and the power are the same, so the output will be either of the one. Now to make this expression we have here look like this, then we have to do some manipulations. Now let's recall. From here we have a to the power of 3 equals 5 to the power of a. So from here guys, by introducing natural log ln to both sides of this expression, we have ln of a to the power of 3 equals ln of 5 to the power of a. And from here we have this one to be 3 ln of a equals a. This will come down, we have ln of what? 5. Let's divide both sides by 3. This will cancel this. Then we have ln of a equals, this will now be, by dividing both sides by a 2, here will also be divided by a, and here we are going to have it to be a equals ln of, this will cancel this, 5 divided by 3. Now guys, we got to recall that when you have e to the power of ln of x, this will always give us back our x, because the exponent and the natural log normally cancel out. Then we get back our s, which implies that when you have e to the power of ln of a, this will give us back our a. So by applying it to this, we are going to have ln of a divided by, instead of this a, we replace it with this one, e to the power of ln of a equals ln of 5 divided by 3. Now we got to recall from law of natural log, when you have b divided by x to the power of m, this can be written as b then multiplied by x to the power of minus m. So by applying this one here, we are going to have this as ln of a dot e to the power of minus ln of a equals ln of 5 divided by 3. So from here, we want to make sure that the base here is the same thing as the power here. But mind you, we have negative here. The moment when we multiply through by minus, by multiplying through by minus here, then when you multiply this one by minus as well. So from here, multiply by this, we have it to be minus ln of a, then multiply by e to the power of minus ln of a equals, minus multiply by this, we have minus ln of 5 divided by 3. Now, to apply W Lambert function, we have to introduce W Lambert function of this is minus ln of a, then multiply by e to the power of minus ln of a equals W Lambert function of minus ln minus ln of 5 divided by 3. So from here, we have this. So far the base and the power are the same. We got to recall from here, from the general expression of W Lambert function, the base and the power are the same. So we have either of the one as the outputs. So likewise from here too, we have this as this. So we're going to have here as minus ln of A equals W Lambert function of minus ln 5 divided by 3. So we have this as this. Now from here, when you have this, we can take this negative back as ln of A to the power of minus 1 equals W Lambert function of minus ln of what? 5 divided by 3. Now, to get out of this natural log, we can take the exponent of both sides. We have e to the power of ln of A to the power of minus 1 equals e to the power of W of minus ln 5 divided by 3. Now, we told you that this one will normally cancel this. We have e to the power of minus 1. A to the power of minus 1 equals e to the power of W Lambert function of minus ln 5 divided by 3. Then from here, we have this as 1 divided by A equals e to the power of minus ln 5 divided by 3. When you cross multiply, we have A multiplied by e to the power of minus ln 5 divided by 3 equals 1. So to get this, we have our A to be equals 1 divided by e to the power of W Lambert function of minus ln 5 divided by 3. Now guys, we have to take note that, let's take note of this. But mind you that W Lambert function of minus ln 5 divided by 3, this, when you press this one, what you're going to see there is does not exist. Though it's a complex solution, it has no real solution, and which implies that our A equals 1 divided by e to the power of W minus ln 5 divided by 3 does not exist. That is no real solution because of this negative. Even by considering the question given to us, we have square root of x minus 1 all to the power of 3 equals 5 to the power of square root of x minus 1. And the moment when we assume this one to be equals variable a, when you have a to the power of 3, and this one we have 5 to the power of what? A. Now, by using the graph, this one is cube. A to the power of 3 is cube. The graph of cube normally looks like this. The graph normally looks like this. And we have this one to be 5 to the power of A. This is an exponent. We normally have the graph move like this. And from here, it is obvious that for this line that is moving like this, for this line that is moving like this, they are parallel to each other. Sorry, this line has no point of what? Intersection. And in that case, if there's no point of intersection, no real solution. Because no point of intersection. From here, no point of what? Intersection. And this implies that we are not going to have any real solution. Though we can have a complex solution, but no real solution for this problem given to us. And here are the steps.